everyone. We're going to talk about special products of polynomials. And this is a special product. Special because, first of all, if you notice, both of these binomials are exactly the same binomial. I like to call these twins. And what's special about them is that they have a certain pattern. And here's the pattern. Let's do FOIL. If we use the FOIL method to find this product, we would first do F for FOIL, which means the first term with the first term. Multiply those two, x times x, x squared. The O in FOIL, let me write out the letters FOIL. FOIL means first times first. O means the outer terms. That means x times 3. So x times 3, those are the outer terms. That gives you 3x. And then we do the I for inner terms. That would be the innermost terms, the 3 and the x here. 3 times x again. And then the last terms, which would be 3 times 3, and that makes 9. When you're done doing FOIL, we collect like terms. So x squared plus 6x plus 9. 6x's because 3x's plus 3x's makes 9x's. Okay, so here is your answer to the product x plus 3 times x plus 3. Now, let me write this down here more nicely. X plus 3 times x plus 3 equals x squared plus 6x plus 9. Now, here's the pattern that you should notice. This last number in the trinomial, which is the constant number, that number comes out of squaring this 3. 3 squared is 9. This middle term here, 6x, that comes out of multiplying x times 3, which is 3x, and multiplying it times 2. So 3 times x, 3x times 2, 6x. And the first term comes out of squaring the first term in the binomial, x squared. So let's do another example without using FOIL. If I have x plus 4 times x plus 4, following the same pattern, I know the first term is this first term squared. I know the last term will be this second term squared, 4 squared, which is 16. And the middle term is going to be x times 4 times 2, which means 8x. That's the pattern. If you don't believe this, go ahead and do FOIL, and you'll see that you get the same answer. Let's do FOIL. X times x, the first term with the first term, x squared. Then the outer term, which is x times 4, that would be 4x's. And then the inner terms, which is 4 and x right here, that makes 4x. And then the last terms, which is 4 and 4. 4 times 4 is 16. And if we collect like terms, we get x squared plus 8x plus 16. You notice we get the same thing doing FOIL or just using the shortcut. Now, this shortcut only works when we have twins. And by twins, I mean the same exact binomial. It only works when I have a product of the same exact binomial. Then I can use this shortcut. And again, this would be x squared. The last term is 25 because 5 squared is 25. And the middle term would be x times 5, 5x, times 2, 10x's. Okay? Another important thing to notice is, since this binomial and this binomial both have plus, all the terms in the trinomial will be plus. Okay? So anytime you have that, it's all pluses. Here is another example. What if I write x plus 6 squared? Well, this is also a twin because x plus 6 squared is the same thing as x plus 6 times x plus 6. So knowing that they're twins, I can use the shortcut. So let's go ahead and do the shortcut here. The first term squared is x squared. The last term squared is 36. And the middle term is x times 6 times 2. That makes 12 x's. And there you have it. And that's why they're called special products. In the next video, I'm going to show you special products, but instead of a plus, we're going to see a minus. I'll see you in the next video.